Assalamu alaikum and salam jahtera. Today we'll move on to a new chapter. We're going to be discussing about detail survey, okay, which is basically looking at ways, it means methods, how to provide or how to produce a plan. We have looked at the basic measurements in surveying. We have learned about establishing horizontal control as well as vertical control. Now is the time to apply that what we have learned in producing a map, or to be more precise, to perform or to conduct a detailed survey. So what I have on the screen now, what you can see on the screen now is an example of a plot or a map or a plan as a result of a detailed survey conducted. So you could see that this is something that necessary whenever we want to build something, when there's a development involved, when there's improvement or upgrading. So before we could start doing the design, we need to provide a plan which looks something similar to this. And that's what we'll be looking at, how to produce a plan or a map which is fit for design and construction. Okay, now detail survey and contouring. So what we're looking at, right, it's basically about producing plans. And when we produce plan, we're talking about, we'll be including features or details. So either they are man-made features or natural features. Details like roads, houses, public utilities, telephone pole, electric pole, those are man-made. Whereas natural features will be the rivers, the contour, the trees. Okay? So that's what we are looking at, producing a plan that contains man-made features as well as natural features. We'll be looking also at why do we need them, okay, the use of this plan. So basically it's for design and for construction. So as I was saying earlier, that before you could embark on any development or project, okay, as far as construction is concerned, there'll be the design part, and before you could start doing any design, you need a plan, and not just a plan of the area, but the current plan of the area, so which entails to doing a detailed survey to provide the information that the designers need as far as design is concerned. Then obviously in the plan we'll have contours, and based on what we call spot heights, these are the points that we observe in the field, and from those spot height we have to do what we call interpolation in order to provide the contour. We'll be discussing that later in coming slides. Then methods, basically the common methods that normally people employ doing detailed survey is either the tachymetry method or total station method. We will be also looking into that later. Okay, so that's in that case what we're looking at, okay, as far as this topic is concerned. Okay, as introduction, detailed survey is basically all about producing plan. For whom? For designers and engineers, okay, before we could start planning to do any development or any improvement of some kind. So when we say detail, either man-made or natural features, and please bear in mind that all these features that we'll be measuring, we'll be doing it from a control points. Okay, we'll be doing it from control points, which we now know how to determine their positions, either in horizontal or vertical planes. Okay, so when it comes to doing detailing or doing the survey, one of the most common things that comes to mind: how many points do I need to produce? How many points do I need to measure? Okay, so there's no fast and hard rule about that, and there's no one single answer to that. Well, probably the best, safest answer will be enough. Okay, enough points to produce a plan that suits the particular application. So if you're doing it for construction or engineering, so you have to have the important things, the things that matters as far as engineering is concerned. But generally, one of the factors that will be determining how many points do we need will be the terrain, whether it's undulating or a flat area. Obviously, undulating area would mean that we probably need more points so that we can represent the area more accurately, as opposed to flat. Okay, probably a few points will be suffice, as long as we get a picture or some indicator on how the contour of the area is. Okay, and purpose for design and for planning. So for that sense, you have to include utilities in the mapping, in your detailed survey. Important things, the roads, sewer lines, building positions, existing roads, drains. So because those things matters when it comes to design. So we have to provide a plan which has as much information as possible, okay, so that nothing will be overlooked during the design stage. Time, of course, if you have time to spare, you probably could observe more points. Okay, if you don't, then it'll be limited. If you're on a time frame, then you probably have to plan, single out the important ones, and observe what you need. Do not go measuring something that you don't really need and you're spending unnecessary time doing it. And obviously the last thing will be cost, budget. Okay, if you spend more time in the field, of course it will cost more, and conversely, spend less time, cost less. But then we don't want to be sacrificing the important points that we need to measure. So these are the things that we will look at, or you have to weigh in the field between time and the cost. Okay, we don't want too many and we don't want too little. And we want, as I said just now, we need what we call enough point in order to produce a complete picture of the area in terms of the info. Is it good enough, or it's complete for the design and the construction process? Okay, so what are the methods of detailing? There are a fair amount, a fair number actually, but I'm going to concentrate on with those two, the offset or triangulation and the radiation method. So these two methods, which I think are the most common and straightforward approach to be employed. So what does offset mean? Okay, if I just click on that, offset simply means you will have a baseline that could be your station, okay, station A, station B. Then if you got a tree, for example, there, to find the position of the tree, you probably just need to measure that line and measure that line at a 90-degree. So that's offset. And similarly to that point of to the other tree. Or perhaps in the next figure, you probably want the corner of that building. Then you just measure that distance and that distance, as well as those and that one, to get the position of the corner of the building. So that's basically offset and trilateration. Those are the things that the basic methods. One of the four basic methods in surveying. Okay, in measurements. Okay, so that's offset or trilateration. So what we have next, excuse me, got that one wrong. Okay, is the radiation. Okay, radiation involves the observation of angle and distance. So just click on that one, then I go to the next one. Okay, you could see that. Let's say A and B are your travel station. To get the location of that tree, you observe an angle, you observe a distance. So that's basically radiation. Okay? So which is, I think you can imagine now, if you have a total station, simply set it up on A, set it to B at a value that you've chosen, then just measure theta and measure the distance, and that will automatically give you the position of P, which is quite straightforward. Okay, now as I said just now, when we are, because you will be likely using most of the time a total station to do your detailed survey, so I would imagine that you'll be using the radiation method rather than the offset or trilateration. But however, if you have very short distances to a detail along the traverse line, you can always use offset. You got to limit the distance though, because the longer the line that you measure with a tape or some sort, so error will crop into your work. So limit it to maybe about 5 meters or so. But then again, that's not a rule. There's no rule about that. But it's just a personal choice. So anyway, detailing methods. As I say, you can either use offset or ties. You use tape. When you use a tape, you only obtain the horizontal distance. Sorry, I'm trying to say that you only obtain horizontal position. Okay, so you won't be getting any height information or radius level, and you need to do some kind of leveling, okay, in order to obtain the radius level of the point if you need. So if you require, so but if you don't, if you're only concerned with horizontal position, then you don't need to do a leveling or some other means of determining heights. Okay, and the second one, the most widely used and quite straightforward to be employed if you have a total station, would be radiation. Okay, you either use your total station or your stadium method using what we call the tachymetry. Okay, and any points that you observe, you automatically will produce the 3D coordinates, the easting, the northing, and the height or the radius level of the point you just measured. So you get everything at one go rather than having to do two separate jobs, one for horizontal and one for vertical if you happen to use the offset method. Okay, that slide just to give you an idea, just to show you what are the common symbols that we use in detailed surveying. Okay, just as a guide. Okay, I'm sure there are there's so many other examples. Okay, but look something schematic rather than a picture. Okay, when you draw a tree, you do something like that. Okay, that's acceptable rather than drawing a tree like that. Okay, which is not good. Okay, we don't do that. Okay, when we provide plan for engineering purposes. Okay.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.